So as we continue our study of probability, we're going to start to look at how we use combinations, permutations, and the fundamental counting principle to help inform us how to do probability and essentially count elements in events and in the sample space. And so to do this study, what we're going to do is we're going to focus on some problems from the textbook. Those problems are going to be on page 639 to 640, and I'll be doing those problems in this video and then assigning some to you. And then your job, you want to make sure that you read the textbook and look at some of the problems that they do as well. Ours will be similar, but slightly different. And so here's the first problem we're going to do. 3 men and 4 women line up at a counter in a store. How many ways can they line up? And then B is same as A, except how many ways can they line up except the first is a woman and the gender alternates, woman, man, woman, man, woman, man. And then finally, the last question is we want to find the probability of question B, where a woman is first and the gender alternates. Okay? So let's set up for that problem. So I shrunk this a little bit so we could see it. And the first question we want to answer is question A, which is, and how many ways can the women line up, or the people line up? Well, there are 7 total people, and we've done this before. They're just going to line up, so the order matters, who's first, who's second, who's third. So this is a permutation, and we're going to choose all of the people. And so therefore we could write this as a permutation of 7, choose 7, which is equal to 7 factorial over 7 minus 7 factorial, which is 7 factorial over 0 factorial, or it's just 7 factorial, because 0 factorial is 1. And so then we could multiply that out. That's 7, 6, 5, 4, 3, 2, 1. Multiply that and get our solution. So I'm not going to get the solution right now. I want to talk about a couple options. We could have just said that we had 7 choices for the first person, 6 for the second, 5 for the third, etc. And that would give us an alternate way using the fundamental counting principle. Both of would have been correct. Part B. Part B then says, we want how many ways can they line up if the first is a woman and the gender alternates. So this one I'm going to do by fundamental counting principle. I have 7 total people and I have a woman here. And the first one has to be a woman, so I have, 4 choices. Then I have a man. I have 3 choices there. A woman, because now I got to alternate gender. I have 3 choices left. A man, I have 2. Woman, I have 2. A man, 1 left. And then the last leftover woman. So if I multiply those together, that will give me the number of ways to get all of the ways I can get the first is a woman and the gender alternates. And then finally, question C wants us to find the probability of B. Well, what would be the probability? The probability would be B divided by A. So essentially, I could have calculated these on a calculator. I didn't. So I'll just write what I got. So it's 4 times 3 times 3 times 2 times 2 and then some 1s over 7, 6, 5, 4, 3, 2, ignoring multiplying by 1. And as you can see, right here is a 6. then I have a 3 and a 2 and a 4, which I can cancel. And so my answer is just 1 over 7 times 5, or 1/35. And that would be the probability. And that's a very typical problem. Notice I could have used permutations right here, or I could have used fundamental counting principle. But either way I do that, this gives me this answer here, and B gives me the numerator, and the answer in A gives me the total number of options, and that's the denominator. So the first few problems are going to do this, where they kind of walk you up to a solution. So this last problem, suppose you have a state lottery, and suppose this lottery has 52 numbers, and to win the lottery you have to pull 6 numbers out. Now, and just so you know, each ticket's $1. And what you want to do is you want to find the probability of winning when you purchase 1 ticket, and then you want to find the probability of winning if you purchase 100 tickets. So we'll set this up and solve it. So if you remember lotteries, when you choose 6 out of 52 numbers, does order matter? And you're correct, order does not matter. It doesn't matter if you get a 1, 2, 3, 4, 5, or 6, or a 6, 5, 4, 3, 2, 1. Those are the same winning numbers in that case. So order doesn't matter. So in this case, we're going to have to use combination to solve this. And so what we want to do is we want to find the total number of possible 6 ticket combinations there are. And to do that first, that's just a combination of 52 items, and we choose 6. And so I'm just going to leave that like that. We can turn this into a calculator problem in a moment. The next thing I want to do is I want to then find the probability of a 1 ticket winner. So I have 1 ticket, it's the winner. What's the probability going to be? Well, the number in my event is 1 ticket out of a combination of 52, choose 6, which I can figure on a calculator. So whatever this answer is, that's going to be my probability. And then finally, I need to find the probability of winning if I purchase 100 tickets. Well, since I have 100 tickets, that's the number in my event, and the number of possible tickets is a combination of 52, choose 6. And so that will be my final answer. All right? Any questions on that? Okay. I'd like for you to come to class tomorrow ready to work on these problems. It'll be a short assignment.